proofs with quadrilaterals. And remember these properties of parallelograms. Basically what you're doing is if you're given a parallelogram, you can use one of these 5 properties. Opposite sides congruent, opposite sides parallel, opposite angles congruent, diagonals bisecting each other, and consecutive angles being supplementary. So let me show you how this is going to work. So we're given this parallelogram. We know that segment AP is congruent to segment CQ. We want to prove R is the midpoint. Okay, so let's use this property of the parallelogram really quick. We know it's a parallelogram. So what I'm thinking is in this proof, by the way, that's my parallelogram symbol. We could use that all the time. AP congruent to CQ, all that's given. So because it's a parallelogram, I know opposite sides are parallel, and that can give me a pair of alternate interior angles. So I'm going to first say that AB is parallel to CD, and that's by the definition of a parallelogram. And then I'm going to say that angle QCR is congruent to angle PAR, and that's going to be true by our AIA conjecture. Remember vertical angles? Angle QRC congruent to angle PRA, true by the vertical angle conjecture. And now our triangles are congruent, and then the sides are congruent by CPCTC. Triangle QRC congruent to triangle PRA, and that's going to be true by angle side. So really these proofs are just triangle proofs. So the only thing that's really different in this proof is that I told you it's a parallelogram. And then you're going to use a property of the parallelograms to then complete your proof. R is the midpoint of QP. I proved the wrong segments congruent. How about that? Let's take that out. And instead, let's say that QR is congruent to PR by CPCTC. That makes a little more sense. So what's the new thing? The new thing is that I use the property of a parallelogram to get me something about the quadrilateral. Let's skip over this one for a second. I know we'll come back to it. Now we'll go here. So notice now I'm trying to prove it's a parallelogram. So we know that parallelograms have like opposite sides congruent, opposite angles congruent, things like that. So basically, when I do this proof, what I want to try to do is I want to try to do one of these properties. I want to show one of these things to be true. So let's see if I can do that. So I'm given parallel to CD. So I'm given these two sides are parallel, and they're also congruent. Well, if I'm given parallel, I know I got congruent angles by AIA. So I'm going to say angle BAC is congruent to angle DCA. I have a shared side. Oh, I'm writing shared side in the wrong spot. I think I got enough now to say my triangles are congruent. So triangle ABC is congruent to triangle CDA, and that's going to be by side angle side. Now, to prove it's a parallelogram, I need to prove one of those properties to be true. So maybe I'll say that this side here and this side here are congruent, and then I'll get opposite sides congruent. That's one possible way to do it. So I'll say that AD is congruent to BC. That's CPCTC. And then ABCD is a parallelogram because the opposite sides are congruent. Opposite sides are congruent parallelogram. And this is something pretty big, Because what this shows us now is that if we're given a quadrilateral and one pair of sides are both parallel and congruent, that quadrilateral has to be a parallelogram. So I'm going to add that to this list too. One pair of sides, both parallel and congruent. That makes a parallelogram. And the reason why I wanted to take a little bit of time to show you this one is because often this is the best way to prove something's a parallelogram, is to show in a figure that you have one pair of sides that are both parallel and congruent. So this is one that I want to kind of work with you on. And here's the hint. The hint is that I'm given a quadrilateral, but doesn't this quadrilateral look a lot like a parallelogram? So since it does, what I'm going to do is I'm going to show that it's a parallelogram first to open up all those properties of parallelograms. I know AD is congruent to CB, and I know AD is parallel to CB. I also know that AJ is congruent to CK. That's all the stuff that I'm given. Okay, so again, notice this. I'm given a quadrilateral, but look at that. That tells me that this thing's a parallelogram because I've got one pair of sides that are both parallel and congruent. So the first thing I'm going to do is I'm going to write parallelogram ABCD because it has one pair of sides, both parallel and congruent. So that's a big thing to take advantage of because now I know that the opposite sides are parallel, opposite sides are congruent. And now let's see where I can go with this proof. I want to prove that I is the midpoint of JK. So I'm thinking I want to prove maybe some triangles congruent. So let's go and do that. I know that AJ is congruent to CK. That's pretty good. Because it's a parallelogram, I know that AB is parallel to CD. In a parallelogram, opposite sides are parallel. So then I'm going to get a pair of angles here, and I'm going to get a pair of angles here. So let's say that angle AJI congruent to angle CKI. And let's also say that angle JAI is congruent to angle, let's see if I went AJ or JAI, I gotta go KCI, all by AIA. You could have done the vertical angles there as well. I just wanted to do something a little different maybe. So now my two triangles are congruent. And that's going to be true in this case by ASA. I got to prove that I is the midpoint of JK. So I want to prove that JI congruent to KI by CPC-TC. And then by the definition of midpoint, I'm going to have I is the midpoint of segment JK. So big idea for today is use a parallelogram to get the properties of the parallelogram to prove things about your figure. Or when you're given a quadrilateral that looks an awfully lot like a parallelogram, prove it's a parallelogram first.